What you've done in the previous chapter is all about equations of motion in one dimension, which means a car going horizontally somewhere, or you throw something up and it comes down. That is a one-dimensional motion, and you should be familiar by now how to use those equations of motion, right? Now, what we are going to do, which you already know, I gave you an introduction to two-dimensional motion, is like two things happening at the same time. A vertical motion combined with a horizontal motion. Now, what did I mention about these kind of motions? The horizontal and the vertical are independent of each other. They are independent of each other. So you can actually work them as two different problems, basically. Because what is happening horizontally and what's happening vertically are different things. In the case of a projectile, this is called a projectile motion. In the case of projectile motion, the vertical part is an accelerated motion, but the horizontal part is a non-accelerated motion, no acceleration at all, horizontally. Okay? So when a football is thrown, the movement up and down is an accelerated motion, whereas the movement sideways is a non-accelerated motion. Again, we are ignoring air resistance and other effects. So if you ignore air resistance and all that, so that's what is known as a projectile motion. So projectile motion is a two-dimensional motion. There are different kinds of projectile motions. Like, let's look at the simplest one. And I'm going to solve this using an example, so you'll understand exactly what to do. Now, I'm doing it my way, and I think that'll be the most efficient way of doing these problems. Now, I don't want to bring in too many variables in the y-axis and x-axis by putting initial velocity VIX, VIY, abbreviating for x and y-axis. I won't do that because then it'll look like too many variables to handle. Instead, I'll show you a method which is very easy, and you can solve even the toughest projectile motion questions with ease. Okay? Of course, you can't make silly mistakes. You have to work the right way. So, the simplest projectile motion will be a horizontal projection. Horizontal projection, that means like projecting something horizontally. That is the simplest one. The next one is angular projection, just going this way. So I'll do the horizontal projection first, and then I'll do the angular projection later. But the technique is exactly the same for both. Okay? Now, what is a horizontal projection? Let's do this in an example. Here is a building. You're standing on top of a building. And imagine that you're rolling a bowling ball off the building. Don't ask me why. You just roll a bowling ball off the building. Okay? And you're rolling it off at 10 meters per second, let's say. And the building is 50 meters tall. The building is 50 meters tall, and you're rolling this bowling ball at 10 meters per second horizontally. So let's see what happens to this bowling ball as it moves. After some time, as soon as it comes off the edge, how fast is it moving horizontally? 10 meters per second. How fast is it moving vertically? How fast is it moving? Velocity? 0. So the initial vertical velocity is 0. You understand that? And the initial horizontal velocity is 10. You get it? So that's how it starts off. So horizontal velocity is 10 meters per second. But the vertical velocity is
Mr. Hunt, specific more combinations.
vertically it is not moving. After some time, what happens? Gravity starts taking effect, right? Gravity starts acting on it. So after some time, what happens is, it is here. How fast is it going horizontally? And vertically, it starts building up its velocity downward. You can see the arrow there. What happens after a little more time? It's moving faster downwards, or horizontally it is 10 meters per second. After some more time, vertically it's moving still faster, but horizontally it's still 10 meters per second. After some more time, it's moving at a good vertical speed, and horizontally it's still moving at 10 meters per second. So this trajectory that you see here is a parabolic path, and that is a projectile motion's trajectory. This is horizontal projection. So again, what's going on? Horizontal velocity is not affected, but the vertical velocity is affected because of gravity. So which one is an accelerated motion, the horizontal one or the vertical one? The vertical is accelerated. Horizontal one is not an accelerated motion. All right, so what, you understand this scenario right now. Question is, where does it land and when does it land? Where and when does it land? So if I roll the bowling ball from this building top, where and when does it land? Now to solve these kind of problems, what you should do is this. Create a table. You split the whole problem into two problems. And what do you write over here? Write horizontal. And on this side you write vertical. So horizontal here, vertical here. So now we are going to split the problem into two problems. Anything horizontal, do it here. Anything vertical, do it on this side. Now this is not only for this problem, for all projectile motion problems. You do the same thing. Okay? Any projectile motion problem, split it into two. And then you work. Now if you look at the worked example and all that in e-text, it won't be showing that way. And that's why students get really confused about it. Because you're mixing two things together, and it's hard to differentiate them. And you use too many variables. We're not going to use too many variables. We still have those 5 variables, which are initial velocity, final velocity, acceleration, displacement, and time. So we still have the same things. Now this side is a non-accelerated motion, which means what is the acceleration on this side? 0. This is acceleration 0. You don't have to write it down after this time you don't have to even write it down because acceleration is 0. So when acceleration is 0, there's only one equation that you can use on this side, which is that equation. When acceleration is 0, there's only one equation that can be applied. How much? What's that? X equal to Vt is the only equation you can use on this side. Whereas on this side, we'll use all the equations of motion. Why? Because this is an accelerated motion, right? This is not an accelerated motion, so there's only one equation applicable. So on this side, you're only looking at three terms, x, v, and t. What's the initial velocity here? 10. What is the final velocity here? 10 meters per second. Do you get it? So I'm not going to write it down. I'm not going to write final velocity and all that. I won't even write it down. Write acceleration equal to 0 in future. I'm not interested in that. Because I'm only interested in these things. Okay? Now on the other side, I'm going to use the same variables. What is VI? 0. See? So you put the respective physical quantities on the respective sides. Anything pertaining to horizontal motion, put it on this side. Anything vertical, put it on the other side. You may use the same symbols, look. But since you're putting it into different columns, You don't have to worry about using the same symbols. You get it? Unlike in textbooks, sometimes they'll write this one as VIX, VIY, subscript upon subscript. Why? You don't require all that stuff. That's why I'm trying to make it straight away easier. Split up. Initial velocity is 0. What else do you know on this side? Acceleration is negative 9.8. What's displacement? Huh? 50. Negative 50. Come on, you should be more conscious about the directions now. Displacement started from here and it's going down. And we are talking about vertical displacement. See, when I say vertical, I mean this, not this. Okay, so this is where it was. This is where it's finally. And that is actually the displacement is this. The shortest. But I'm not interested in that. I'm interested in the vertical displacement only. Vertical displacement means how much has it shifted vertically? Down or up? Down. So minus. So we have already 3 things. Can you find the time it takes for it to land? User equations of motion. So what equation of motion will connect these 3 quantities? You should be familiar with the equations by now. As soon as you think of an equation, it should just flow because you've been using it multiple times. X is equal to? Substitute. Negative 50 is equal to minus 4.9 t squared. So what is t equal to? What is time? Plug it in, plug it in. Everyone should work with me. Take your calculators, plug it in, see who gets the answer first. And everyone should have the same answers displayed on your calculators when you're working. I'm doing it here, but don't just take it for granted. It may be wrong. How much? 3.1. So it's 3.19 seconds. You know what? I told you horizontal and vertical motion are independent of each other, right? But there's only one thing that is common between the 2 sides, which is time. The only scalar quantity is the only quantity that is common between the 2 sides. Because what is happening vertically and horizontally is taking place in the same time, right? So, this is how it goes. If you end up discovering the time on the vertical side, transport it immediately to the other side. So if you discover the time here, put it here. If you discover the time on the horizontal side, take it and put it there. You get it? So this piece of information, the data for time, that data, if you get the data on this side discovered first, take it to the horizontal side. Otherwise, take it to the other side. So whichever side helps first. You don't have to always start the problem on this side. Sometimes you may end up solving the problem this side first. Take the time and drop it on the other side. Get it? Okay. Now we have V, how fast it's moving horizontally. And we have the time. You can find the other one. So X is equal to Vt. How much is that? 10 times 3.19, which is 31.9 meters. Now where is that distance on the picture? Here. This is X is equal to 31.9 meters. So did we solve the problem? When did it land? After 3.19 seconds. Where did it land? 31.9 meters away from the bottom of the building. You get it? So when the bowling ball is rolled off, it is expected to land 31.9 meters away from the building, and it is expected to land 3.19 seconds later. We solved it. Any questions on this? Every problem you're going to do it this way, and you'll find that problems are much easier when tackled in this manner. This format is going to be the format that you're going to use. Yes?
So for a problem like that, after we get the
overall displacement? No. No. Most of the time you'll be asked questions like, what's the height of the building, or what is this? You know, no one actually expects you to kind of measure this distance, like the displacement. That's not a significant quantity that we. So we like to know this and this better. Yes, if you are asked what is the overall displacement of the bowling ball, expecting that the bowling ball did not roll off from there. Okay, if the bowling ball just went and got stuck in the sand, then yes, it will be this distance. Yes, Ethan?
No.
Same question? Yes. Any other questions here? Are you ready to solve the problem yourself? Good. What is that? Good. It's a bomber traveling at 720 kilometers per hour. So you can write down this as a question. A bomber traveling horizontally at 720 kilometers per hour intends to drop a bomb on a target on a target 1,000 meters away. A bomber traveling at 720 kilometers per hour, you should write the words as well, not just the pictures. 720 at a bomber traveling horizontally at 720 kilometers per hour intends to drop a bomb on a target 1,000 meters away. What height should the bomber be flying when dropping the bomb? At what height should the bomber be traveling when dropping the bomb? I'll give you a little time, just work it out. Try to see if you can manage it. The first thing you should be doing is to convert this 720 kilometers per hour to meters per second, because you're not going to work with kilometers per hour and acceleration meters per second square. It'll get mixed up. So you should use one system of units. So change this to meters per second. What do? Divided by 3.6. Yes. So that'll get you 200 meters per second. And I'm going to use this, not this. So this is not going to be used. Only this will be used. 200 meters per second. All right. Use that as the distance, and use that as the speed of the plane. So pulling up the data, initial velocity is 200 here, but the initial velocity here is 0. The displacement known, 1,000. Horizontal displacement is known, 1,000. On this side, we have the acceleration negative 9.8. And we don't have any other information. On that side, we need one more information, one piece of information, but we don't have it. We don't know anything else. Now, since we have two things already over here, we can find the time. So x is equal to vt. So t is x over v, which is 1,000 over 200 meters seconds. So that is going to be 5 seconds. So we discover the time on this side first. And then immediately what you do is take the time and put it there. So this time is transported over there. Now we have three pieces of information. And then you can find height. So basically what you need to find out is this. So x is equals to vit plus half at square, work the same way. And you have, sometimes you have to use the other equations of motion, but yes. Vit plus half at square, so x is equal to minus 4.9 times t square is pi square and the answer is negative 122.5 meters. The negative sign implies the bomb is undergoing a vertical displacement of 122.5 meters downward. Okay? And so if you're looking for height from where it is to be released, just say 122.5 meters above the ground. Any questions on this? Yeah.
Like if the bomb is moving along with the plane, why would the initial velocity be 0?
It is moving with 200 meters per second.
Oh, in the vertical.
Vertical, this bomb is moving downward. The moment it is dropped, right? So when it is dropped, the initial vertical velocity is 0. It is moving horizontally at 200, but vertically it is just not started moving. And after some time, it will start moving downward. No questions here? Good. Now going back to the previous problem. I'm going back to the previous problem. The previous problem was the bowling ball, right? The bowling ball rolling off at 10 meters per second. And when it lands over here, it's moving at 10 meters per second. If I ask the question, what is the velocity with which the bowling ball hits the ground? With what velocity will the bowling ball hit the ground? What velocity? With what velocity is the bowling ball hitting the ground? Now what do you need to do? Is it hitting the ground at 10 meters per second? No, because it's also moving downward. So we need to find this. We need to find the final velocity. So we have the initial velocity is 0. We have the displacement as minus 50. We have the acceleration is negative 9.8. And we need to find out the final velocity. What equation will connect all those? Yes. Vf squared equal to Vi squared plus 2ax. So Vf squared is equal to Vi squared is 0. So 2 times negative 9.8 times negative 50. And what is Vf? 31.3 meters per second. Positive or negative? Because when you take a square root, you'll get two answers, right? Positive or negative? Negative. So this thing is 31.3 meters per second. So is the bowling ball hitting the ground at 31.3 meters per second?
Yes.
Then what about the 10? So when the bowling ball is hitting the ground, it has two velocities. A horizontal component of 10 and a vertical component of. So what do you do for the final resultant? So what do you do? Take the resultant of these two. So this is 10 and this is 31.3. This is going to be a resultant. That's what you need to find out. How much is it? This is 10, right? And this is 31.3. See, this is 31.3. This side is also 31.3. This is 10. This is also 10. Right? So that's 31.3 and that is 10. So how do you find the resultant? Pythagorean theorem. Square root of 10 square plus 31.3 square. And the answer is 32 point. Do it. Everyone works. 32.8 meters per second. That is how fast it is actually hitting the ground. It's not hitting at 10 meters per second or 31.3 meters per second. It's hitting the ground at 32.8 meters per second. But the question is, I asked you for velocity, not speed. If I asked you for speed, your answer stops there, 32.8 meters per second. I asked you for velocity, so what else do you need to find out? Direction. So you need to find the direction. The best way to find the direction is with respect to the ground. So if this is the bowling ball coming and hitting like that, the bowling ball comes and hits like this, you mention the direction with the ground is better. So you can say with the ground. So with the ground is this angle. which is this angle. How do you find that angle? Tan of the angle is opposite over. This is the opposite for this angle, this is the opposite, and this is the adjacent. So it's 31.3 divided by 10. So the angle comes out.
3.13.
Tan of the angle is 3.13. But what's the angle? Work backwards. Second function, 72.3.
Yes. 72. Okay, this is 12 degrees.
Now with respect to the ground, or with the ground. Do you understand how to do it now? So if the question was asking for what is the final velocity of landing, you need to say it lands at 32.8 meters per second at 72.3 degrees with the ground. That makes it all finished, completed. So you can find out every detail of projectile motion by just working with equations. But remember to work on the respective side. You work on the vertical side or the horizontal side. Yeah.
Would it be wrong to say southeast?
No. South. No, we don't have any information of south or east and all that. That is not right. So when something is landing like that, the only information you know is the building and the ground. So you just give your answers with respect to the ground. But you can also say the angle with the vertical. So if something is landing like this, you can also say with the vertical, it makes so much angle, which means you find this angle. That will be the angle with the vertical, which is just subtract. Any questions on this? Projectile motion, okay? So now this is about horizontal projection. Now we are going for angular projection. Angular projection. And what is angular projection? When something is thrown at an angle, like a football thrown like that, that's angular projection. I'm going to solve the entire problem of angular projection algebraically, no numbers. Okay? So, let's say for example, you throw something at a velocity of v. If I'm throwing something at a velocity of v at an angle of theta degrees. If I throw something at an angle of theta degrees with the velocity of v, what happens to it? As it goes, it starts going in a projectile motion and it finally lands there. So this is projectile. So what do you do with this problem? You are only given two things: velocity initial, which is the velocity with which it's moving initially, and then the angle. You will be given both of those things. And the question is, find when and where it's going to land. And remember again, I'm going to work out completely in algebraic terms, no numbers at all, and for a reason. Okay, so this is what's going to happen. What do you do for projectile motions? After you get the picture, what do you do next? Make a table, yes. You're going to make a table. I'm going to make a table. Horizontal, vertical. What is VI? What is VI? You have any information about it? What is this velocity? It is the horizontal velocity, right? Initial horizontal. So initially, is this moving horizontally? Is it moving vertically? So how? With what velocity? With what velocity is it going horizontally? What do you do to get there? Starting with R. Something we did in the previous classes. R. Huh? Not resultant. Resolving. What is resolving? What do you mean by resolving? Splitting a given vector into two components. Here it is. So this vector, I want to split it into this component and this component. I want to split it into two components. So when I'm throwing something at an angle like this, it has two components already. A horizontal component and a... So how do you find the horizontal component? How do you find this adjacent component? How do you find it? V. Isn't that what I said? To find the adjacent component, what do? Take the velocity and multiply by cosine of the angle. What is this component? V. That's the first thing you should do in angular projection. The first thing you should do before solving any problems is split the given velocity into horizontal component and vertical component. So, do you know the horizontal initial velocity now? How much? V cosine theta. And what is the initial vertical velocity? V sine theta. So what happens to, after some time, what happens as it keeps moving, when it is here, what will be the horizontal velocity? V. Should it stay the same? Yeah, because there's no acceleration there. So it will stay the same. What about the vertical velocity? See this and look at that. Vertical velocity is getting reduced. What about here? What's the horizontal velocity? V cosine theta. It's the same thing. But what about the vertical velocity? It's reduced further. What on the very top? Is it moving on the very top? It's not moving? It's moving horizontally. At what speed? V cosine theta. That is always going to be the same. So don't say it stopped moving vertically. It stopped moving. No, it's not stopped moving. Horizontal component is still there, which is V cosine theta. What's the vertical component here? 0. Now what happens after a little more time? It starts coming down vertically, but horizontally it is still V cosine theta. After some time, it is moving faster downwards, and horizontally it's V cosine theta, and it keeps going like that. Do you understand this? Horizontal velocity stays intact. The vertical velocity is affected. All right, what else do you know in this? You know acceleration, right? Minus g. So I'm not putting numbers, I'm not putting minus 9.8, I'm just putting minus g. Where g stands for? What else do you know there? Vertically, for sure. Displacement? How much? Do you know the? Huh? 0. Why? Why? Travis?
Because on the vertical axis it doesn't end up anymore.
That's right. So it started from one level and landed same level. Look at that. It started from here and landed at the same level, which means vertically the displacement is 0. So we have 3 things. Can you find the time? What equation? Yeah, x is equal to bit plus half at squared. Now I'm working everything algebraically, so don't get confused about it. It's the same thing. X 0 equal to minus g over 2. Oh, sorry. 0 equal to, what is VI? V sine theta times T minus G over 2 T squared. I'm just substituting stuff. Instead of numbers, I'm putting all those variables. Now what do? You add G over 2 T squared to both sides. That will be V sine theta times T. What do you do from there? Divide both sides by T. Get it? And then multiply by 2 throughout and divide by G. So you get the time. T equal to V sine theta over G. 2V sine theta over G. 2 times V sine theta over G. This is called the time of flight. See, how long something is going to stay in the air is given by that equation. 2V sine theta over G. So if you are told, okay, a football is tossed at this velocity, at this angle, how long will it be in the air before it's received by the receiver? That much time. Now, is this something that you need to memorize? No. I won't memorize it. So don't memorize. Why? Because not all projectile motion problems are going to be from the same level to the same level, right? If something is going from here to here, yes, that makes sense. This equation works. What if it's projected from here and it goes all the way to the floor? You can't use that equation anymore. So don't memorize any equation. It's not worth it. But understand how it is done, that's more worth it. Okay? You understand that time of flight? What do you do now? Once you understand the time of flight, what do you do immediately? Immediately transfer it on this side. So you transfer it to this side. So we have time is 2V sine theta over G. Now we have two things over here. We can find x is equal to Vt. So what is x? X is 2V sine theta over G times V cosine theta. Now putting them together, x is equal to V squared 2 sine theta cosine theta over G. Now, who's doing trigonometry here? What is trigonometry? Those who do trigonometry should be able to tell me this. What is the identity that can replace this? What trigonometric identity can replace that?
Sine squared theta equals cosine squared theta equals 1.
What can substitute for 2 sine theta cos theta? You should be knowing it by now, because that's a trigonometric identity. It comes from sine A plus B. Have you done sine A plus B? Sine A minus B?
Yeah.
Like sine A plus B is sine A cos B plus cos A sine B? No? Or you still getting there? I don't know. Sine A plus B equal to sine A cos B plus cos A sine B. Don't remember anything? So it comes from there. So sine A plus B, in this case A and B are theta. So sine theta plus theta, which is sine. So this is actually going to be x equal to V squared sine 2 theta over G. Sine of twice the angle. Now this is called the range. This is the range. What do you mean by range? How far it goes. How far does it go? That's called the range. Horizontally, how far does it go? That's called the range. What's the equation for the range? So again, if you toss something, if you throw a stone with this velocity at such an angle, where does it land? Here's the equation for it. Again, is it worth remembering it? Not really. I won't try to remember it because I can sometimes get confused with the 2 here, the 2 here, and the 2 here. So why to bring in an equation out of memory, and if that equation turns out to be wrong, the whole thing is out. So when you're solving numericals, don't attempt to bring these equations. Yeah, these are helpful. Just I'm showing it to you. Now, why I brought it to this format right now is for you to see something more. The maximum range. When can this expression be a maximum? When can x become a maximum? You know, see this, there's a sign, right? What is the range of sine values? Sine of an angle can take values between what and what? 0 and? No, the values. Sine of any angle, always between 0 and 1. Any sine angle, it will always be between 0 and 1. The maximum is? Minimum is? Okay? Maximum is 1. So sine of what angle is 1? 90. That means sine of 90 is 1, which implies 2 theta is 90 degrees, right? Is that right? Because if the 2 theta is replaced by 90 degrees, I get the maximum range. And what's the maximum range? V squared over g. Because if sine of this 2 theta equals to 1, then that's when you get the highest value for x. Highest range, that's a maximum range. And when does this happen? When the angle 2 theta is 90. If the angle 2 theta is 90, what is angle theta? What is that angle theta? 45. Now what does that tell you? It tells you that if you want something to go as far as possible, at what angle should you project it? 45 degrees. Because theta is 45. So if you're throwing a shot put, or discus throw, or hammer throw, or javelin, or long jump, at what angle should you take off? 45. For the best range. If you want the best range, the maximum range, that's the goal, right? For long jump and everything, the best range is what is your goal. So the maximum range that someone can get depends on the speed very much. That's why your takeoff speed is an important thing. I'm not talking about takeoff speed as the horizontal speed. The takeoff speed is that, this one. So at what takeoff speed are you going? That is this one. And at what angle are you going? If you can, launch yourself at 45 degree angle, you'd get the maximum range. So when people try multiple times, they sometimes fall short. That's because they just fail to make it 45 perfectly. You understand what I'm saying? So if you get the 45 degree angle, you can get the maximum range, because then it will go further. So if I'm throwing something at 45 degree angle, this is how it goes. If I throw something at 45 degree angle, that's the maximum range that you can go to. Now what if I throw at 30 degree angle? If I throw at 30 degree angle, what will happen? It will land there. Right? If angle theta is 30 degrees, what is 2 theta? What is sine 60? What is sine 60? 0.866. That means what? If this is the maximum range, this is going to be 86.6% of the maximum range. Do you get it? Get it? Now what if you throw it at 60 degree angle? It will land at the same spot. So 60 degree angle will land at the same spot. Why? Take 60 and multiply by 2. So if angle theta is 60, what is 2 theta? 120. What is sine 120? 0.866. What if you throw at 10-degree angle? Look at that. That's 10-degree angle. The launch is very flat. You know, in football when they do the kick, you see that very clearly. Sometimes the kick is very flat, so it doesn't go far, right? And sometimes the kick is too high up, so it goes like this. Well, the best kick is when it's at 45-degree angle. That's when you can make it go farthest. So 10-degree angle gets you there. What is sine 20?
23.40.
Whatever. And then what is the other angle that you get exactly same spot? 80 degrees. So what is 80 times 2? 160. Sine 160. Same thing. So what do you understand from here? What do you understand from there? All complementary angles of projections will get to the same spot. You get it? What's complementary angle? Angles that add up to 90. So 10 and 80 add up to 90. 60 and 30 add up to 90. 45 adds up 90. What if you project at 0 degrees? It lands at the same spot. And the complement is 90 degrees. If you throw something at 90 degrees, it goes up and lands at the same spot. Okay? So that is the range. So the maximum range is when it's 45 degrees, and all complementary angles of projection will get you to the same spot. Now let's find out the maximum height reached. This one. For any angle of projection, what's the maximum height reached? So I'm going to take this off. To find the maximum height, our problem starts here. Look, our problem starts here and ends here. To find the maximum height, our problem starts here and ends here. We're not interested in anything else, right? So between these two locations, Griffin will tell me. Between these two locations, tell me what is it, VI? So that's VI, right?
Right.
What is A?
Negative G.
What else do you know between those two locations?
Yeah.
Do you know VF?
Yes.
What is it?
0.
Good. The vertical velocity at this point is 0. You should be conscious of that. This is vertical velocity 0. And what are you looking to find? You're looking to find this height. So x is equal to height. That's what you want to find out. So what equation will help you to get there? Something that doesn't have time. So VF square is equal to 2AX. Substitute. VF square 0 equals to V sine theta square plus 2 times negative G times height. So if you bring it to the side, 2GH is equal to V square sine square theta. So what is H? V square sine square theta divided by 2G. That's the maximum height reached by a projectile. That's the maximum height reached by a projectile. Now, is it worth remembering these equations? No. You can see that there are 2's appearing in different places. There's a 2 here, there's 2 here, there's 2 here. And for the range, there were like a couple of things. So if you kind of ask me to tell one of these equations, I will not say it because I don't remember it. I don't make an attempt to remember it. Why? Because it's not really useful. Because those equations are only true for same level projection, same level landing. The height, yeah, the height is probably useful because it doesn't have to be same level landing. If I'm projecting from here and it goes down there, and if I want to find out what height it did go all the way, then yes, this equation will help. Yeah, but you don't have to use the equations, you can use numbers straight away and get there. So I've shown you those equations just for you to understand some concept, which is complementary angles will get to the same spot, angle 45 degrees, best angle of projection for maximum range, and so on. So do you understand this part? Good. Now let me give you a problem, and you see how you do it. So I'm throwing something at 20 meters per second at an angle of 60 degrees. Find when and where it will land. Find when and where it will land. What do you do first? Set up table, but and resolve. So all angular motion, all angular projections start off with resolving. The first thing you do is resolve it. This 20 meters per second is not our important, not the number that you're looking at. We are wanting to resolve it. So resolve it. What is this component? 20 cosine 60. 20 cosine 60, which is 10 meters per second. And what is the vertical component? 20 sine 60. That should be 17.32 meters per second. So we have the two components ready. Now go to the table. Go ahead, I'll give you some time. Whenever you do any problem, always do the problem from one starting point to a finishing point. Between this point and this point, what are the what are the pieces of information you know? Initial velocity horizontal is 10. Initial velocity vertical is? Acceleration vertical is? Or is it displacement? And then find the time. Yeah. So find the time. Use x is equal to VIT plus half AT square. 0 equal to 17.32 t minus 4.9 t square. So t will be 17.32 divided by 4.9. And the answer is 3.53 seconds. As soon as you get that, put it down here. T is equal to 3.53 seconds. And then x is equal to Vt 10 times 3.53, which is 35.3 meters per meters. That's it. So when does it land? After 3.53 seconds. Where does it land? 35.3 meters away. Yes, any questions?
Wouldn't that be t squared equals 17.32?
Yeah, but we're knocking off one of the t's, so
Oh, okay.
I skipped a step. Any questions on this? All projectile motion problems are going to be worked out exactly the same way. Now if you ask the question, okay, how fast is it going at the top? How fast is it moving at the top? How fast is it moving at the very top? I'm just asking, how fast is it moving at the very top? 10. You don't have to ask me horizontal or vertical. How fast it's moving, right? It's moving. So how fast is it moving? 10 meters per second, because the only velocity over there is the horizontal component, which is 10.